In this video, we're going to be using the elimination method to solve the system of linear equations when we don't already have matching opposites in our equations. So notice here, in our first example, we have x plus y equals 2, and we have 2x plus 7y equals 9. If we look at our x's, they do not match, and if we look at our y's, they don't match. So we're going to have to multiply by something to make them match. But we have to decide first what we want to go away, to eliminate, either our x's or our y's. It ultimately doesn't matter what you choose, as working through the problem will give you the right answer. But in this one, I think I want to multiply by a 2 on the top to get my x's to match to go away. But doing that is only going to make my x's match, and I need them to be matching opposites so they'll eliminate. So I actually need to multiply by a -2. So I'm going to go ahead and take that, and I'm going to distribute, and that's going to give me a -2x minus 2y equals -4. Again, make sure you go all the way to this last piece right here too. And then I'm going to write my bottom equation, 2x plus 7y equals 9. And now I'm ready to add those together. So my x's go away as we had planned. And then we're going to have 5y equals 5. We'll divide both sides by 5 and get y equals 1. Now we're going to take that one and we're going to plug it into either our top equation or our bottom equation. It doesn't matter which one we choose. We should be able to get the right answer. Just whatever you think looks easiest to you. So I'm going to choose the top equation. So I'm going to take the x plus y equals 2, and I'm going to replace my y with the number 1 that I got. So I have x plus 1 equals 2, and I'm going to solve to get the x by itself, and I get a 1. And that's going to give me a solution of 1, 1. Now, normally what we would want to do here is we want to plug this in and check it and make sure it works. We do that by plugging the x and y into the top equation, and into the bottom equation to make sure that they come out with the correct answers. In this case, they do, and so our solution is 1, 1. And again, we got that because we have an y value of 1, and we got an x value of 1. And again, we checked those out, and it worked. Let's take a look at this next example. If you'd like to, try it on your own and see if you do all right. See if you can get it right. Push pause, work out the problem, and then when you're done, push play, and let's see if you got it right. So here we have 11x minus 20y equals 28, and 3x plus 4y equals 36. So I can make my x's match, or I can make my y's match. If I make my x's match, I need to multiply by an 11, but if I make the y's match, I only need to multiply by a 5. And my y's are already negative and positive. So making my y's match might be the faster choice here. So I'm going to go ahead and multiply by a 5 to all 3 pieces. So I'm going to go ahead and write down my first equation, 11x minus 20y equals 28. And then I'm going to write down my distributed equation, which is 15x minus 20y equals 180. And then I'm going to add these together. So that's going to give me a 26x. My y's are going to cancel out. And then I'm going to get a 218. I'll divide both sides by 26 to get the x by itself. Except I think that my 218 isn't right. As I look at the math there, that should actually be a 208. There we go. Carried my 1 a little too far. So when I divide that by 26, I'm getting an answer of 8. So I'm going to take that 8, I'm going to plug it in. Again, I get to choose between the top equation and the bottom equation. It doesn't matter which one I choose, as it will give me the correct y value no matter what. So I'm going to choose the bottom equation because it has smaller numbers. So 3x plus 4y equals 36. I'll take out my x, and I'll replace it with the 8 that we just got. So that gives me 12 plus 4y equals 36. I'll subtract 12 from both sides to get 4y equals 24. Then I'll divide both sides by 4 and get y equals a 6. So here I have a value of 8, comma 6, and I got the 8 from right here, and I've got the 6 from down here. And if I plug those into my equations, again to my top equation and my bottom equation, to make sure that they work, when I do that, I find that they, in fact, are a solution to the system. So even if you don't have matching opposites, you can create matching opposites simply by multiplying one equation by another, or by a number. And sometimes you even have to multiply both equations by number, but we'll save that for a different video. But let's take a look how we can use this same idea to solve a problem, kind of a puzzle. So here we have the sum of two numbers is 22, and the difference is 6. So what exactly are those two numbers? So our first piece, the sum of two numbers is 22, can be written as x plus y equals 22. And the difference means those same two numbers. Now we're going to take x and y, we're going to subtract them to get 6. So notice here that our y's are matching opposites. So we're able to add those together to get rid of the y's, which gives us 2x equals 28. By dividing both sides by 2, we get an answer of x equals 14. So now we need to decide which equation we're going to plug that into so that we can get the y value. So we're going to plug it into the top equation. So we're going to plug in x plus y equals 22, but instead of the x, we're going to plug in the 14 that we just got. Now we're going to be able to subtract 14 from both sides, which is going to give us y equals 8. So that's our y solution. Now we want to make sure that we check them, so we're going to plug them into both equations. So we're going to say 14 plus 8, and we get a 22 just like we're supposed to, and 14 minus 8, and we get a 6 just like we're supposed to. And so that tells us that the two numbers are 14 and 8. And so we can use systems of equations to help us solve number puzzles as well.